Hello, I hope everybody's enjoying IaCConf. This session is going to be Replace Terraform Module Forks with Automatic Policy Transformation Rules, and it's going to be run by Anton Babenko. And then just a couple of housekeeping things. If you have any question and answers that you want to kind of put in the chat, I would do so in the Q&A box, so that way when it comes time for some questions at the end, we can kind of run through those. And then if you have any questions that you really want to have answered, we can use the upvotes for that. All right, I'll leave it to you, Anton.
Thank you very much, Gabriela. And yeah, it's my pleasure to attend this conference. I knew about existence of this conference for quite some time, but it's my first time when I actually have possibility to present. And I'm really excited to present the subject which I was having in my head for a very long time, since, approximately since first time I discovered Terraform and figure out that, well, why cannot I use variables inside life cycles, right? You probably know about me already. Well, my name is Anton Babenko, and since 2015, I've been doing a bunch of different Terraform projects. I'm also AWS Community Hero, and you may have used Terraform AWS Modules and maybe pre-commit Terraform as a collection of different Git hooks to help you with Terraform quality standards. Recently, I worked on Terraform skills because, as we all know, there is AI. And even after listening to Corey's talk, I was thinking like, yeah, it was a problem that AI generates bad Terraform code or doesn't know anything about it, like it can hallucinate. So that's why I spent quite a lot of time making this Terraform skill. And it, combined with official MCP server by HashiCorp, does miracle. I mean, I have almost no problems with it. Of course, I use a bunch of other tools as well, but it helps. So if you want to improve your AI way of generating Terraform code, and not just generating, but working with Terraform in general, please take a look. I also work on Compliance.tf, which is partially related to this talk, but I want this talk to be not about Compliance.tf, but about the problem which you can solve. And I will show how you can solve it do-it-yourself way. Also, Terraform best practices, serverless.tf, and a few other resources you may have seen before. So this talk is about a couple of things. So first, the fork graveyard, which many of us have experienced in the past. And then I will explain the difference between validation versus transformation. And I will explain what is actually operational rules. And I will share the provider and explain how to implement all of this yourself using many different open source tools, which you have already used if you use Terraform. And also, I will explain the migration path. So the fork graveyard, we already may imagine the situation where we start using Terraform, we found some module which doesn't have everything what we want, so we fork it, we add our functionality there, and now we are in maintenance burden for unknown amount of time. And we will miss different upstream patches, and it will be our drift and something what we have to handle. As one of a company I talked to has said that they forked Terraform AWS modules for few modules, hard-coded security, and now they start maintaining them forever. That's pretty much what I have heard, and that's pretty much many companies who use open source Terraform modules went through. So of course you may think that, well, that's a lot of accounts, that's a lot of modules to maintain. Overall, DevOps engineers or SRE engineers, so to speak, spend roughly 40 hours a month just to make sure that they implement missing functionality, which we already have in the upstream version of the module, or debug different edge cases, which again we have implemented in central Terraform AWS module repositories. So let's look into validation or transformation. So the key point here is that policy as code can reject your plan. And it's pretty hard to do that policy as code mechanism can rewrite your module. Everything is possible, but it's not the question of whether you should use OPA or Sentinel or conf test to add a lifecycle block. If it's missing, then plan will fail. That's it. And someone will still have to fork the module and implement this functionality. So where this potential misconfiguration can happen? Obviously, if you are typing HCL code, then everything can be placed there. Some misconfigurations, some wrong defaults, some wrong parameters, copying from ancient example, everything can happen. If you are specifying variables, then you may specify some unsecure or not safe default values there. If you're writing module source, then most Terraform AWS modules does not limit you on what you want to put there, and this is intentional. Also, if you run plan, then different verification across resources may not be always discovered in the right time, right? And also, if you run policy check, as I said earlier, it can just say that something is bad, but you will have to fix it somehow later. So if we look into these two different enforcement models, where policy validation runs at plan time and it evaluates the plan and decides plan or fail, policy transformation, which in my case happens at download time, or when you run Terraform init and hit a certain registry endpoint, it already contains code which is updated, which was rewritten for certain requirements, and so on. So different kind of dynamic workarounds, which historically was not possible to implement because lifecycle cannot be placed dynamically, or provisioner was placed there, but you know that putting provisioner is a bad thing to do. And this kind of functionality will be removed when you use policy transformation at download time. So there are two different types of checks. One is, so to speak, compliance controls, where things are strictly required. For example, encryption is required, or public block access should be required, and so on. They're strictly related to your audit process. So if you don't do this, then most likely we'll have issues during audit. While operational rules is a new thing which I'm talking about here, is something what you should do. For example, lifecycle protection will unlikely to affect your audit, but it will significantly improve life of DevOps engineer who doesn't have to maintain the whole module with single line change. Or provision removal will be a great addition so that you reduce amount of potential threats and people will not be able to execute malicious shell scripts when instance is created, right? Also, things like different instance type restrictions as well as different naming conventions is just helping you to have a good operational scope and is not related to audit in most cases. Well, I don't have possibility to run code here because, well, you can see my slides. I think they're awesome. But you can just imagine that on the left side, I showed before where I'm using Terraform AWS module from official HashiCorp Terraform registry. And when I run Terraform init, then it downloads it. And then when I run make before or OPA before, the only thing which is happening there is that it checks Terraform plan, and then it checks inside of plan, does it have this lifecycle block presented? And obviously it does not, because it's official public Terraform AWS module. While on the right side, after you use rules registry, which is sourced from registry Compliance.tf, and then inside of these three dots, there is exactly the same module source. You can specify rules you want to apply. For example, in this case, a rule called prevent destroy data. And then when you run it through OPA, it will not be able to identify lifecycle prevent destroy there because it was removed as you download this module during Terraform init. So this is only difference which you see here. So the overall difference for the user is just one line of the code, where you change instead of loading from one official endpoint to another one, and you append different rules you want to use there. You don't need to fork. Obviously, you don't need to do any modifications. You receive code which is already in expected condition. So there are four categories what people typically change inside of modules. There are a little bit more categories, to be honest. I realize it when I talk to customers, but overall there are four. So the first one is when you want to work around limitations of HashiCorp, which we know since 2016. There are open issues there. OpenTofu helps with some of this, but not all of them. For example, add or modify lifecycle blocks, or strip the whole entire blocks, for example, provisioners, or you may want to specify certain things to be allowed, for example, different instance families or different AMI IDs or certain regions where infrastructure can be deployed. Most of these things are pretty hard to do inside of reusable modules, even if they span across multiple teams, because different teams may have slightly different requirements, and then it will be hard for them to get like one canonical example for which satisfy all of them. And also different regex-based cleanups. For example, you may want to make sure that some credentials are never ever in any situations possible to expose, or you want to make sure that deprecated attributes are never ever placed there, or debug flags and so on. So overall, it's like this prevent and destroy data, which are typically applicable for S3, RDS, and DynamoDB, because you simply don't want to destroy data in production environment, but you want to be able to do this in dev environment, for example, or even ignore tag changes, which is quite common request, or ignore auto-scaling changes, right, inside of DynamoDB tables, for example. And no provisioner is one of my favorite, where I never ever allow provisioners to be used. If you want to use them, please find any other solution, but no provisioners. So prevent destroy data is pretty much just adding 3 lines of code to S3 buckets and KMS keys, while no provisioner is just removing of provisioner block from null resources or from any other resources where provisioner local exec specifically was used. Restrict instance type is another way to make sure that GPUs and high memory families, which can cost up to, I think, $25 per hour, is not an option. So we have to find another way. And I think about different types of of rules. So most common what we've heard is that detective, right? OPA tells us for many months, not months, sorry, for many years, that it can identify Terraform plan, it can evaluate Terraform plan, and then it can decide whether something is okay to be applied or denied. To my mind, this is already extremely late. First of all, you will need to provide credentials to be able to run and to get this plan, and it's already too late. With AI specifically, I don't want to do anything else like in 5, 10, 20 minutes. Only now, if I write some code, I want to know immediately that my code is good or is having potential to be applied. So detective is good, but it's more like legacy, I would say. And preventive is exactly the place where a solution should happen. So if something should be denied, well, then I don't have to even know about it. Just remove from the code, provide me the solution where this misconfiguration can never happen, and I will be glad. So preventive is the future to my mind. And residual is something what happens pretty much outside of Terraform, good or ClickOps, and different pipelines, where things are pretty much not in our control. Console ClickOps is a typical example. So I still have some time. Let me talk about one of my favorite things, which I have kind of developed, but I really want to have feedback from the community. So the raw AWS resources can still slip past through different module rules. Think about this, that you write Terraform code and you don't want to have any extra tool which can control whether you are allowed to apply certain code or not. You already run, let's say, Terraform apply, and it's using AWS provider, and the AWS provider is doing gRPC calls like AWS core and AWS provider. They do speak to AWS endpoints, right? And the provider which I have developed is under namespace Compliance.tf, is staying in front of official HashiCorp AWS provider. It has extremely small surface of what it can do. The only thing which it can do is that it verify whether something is okay or not. So, for example, if you run Terraform plan with the code which is like handwritten resources, but it can be also any Terraform resources, any nested resources, anything what any tool like Checkov or Trivia cannot properly dispatch. You run any Terraform code, then Terraform code calls Compliance.tf AWS provider, and AWS provider, Compliance.tf AWS provider, figure out whether this is something what has to be even passed through to HashiCorp AWS provider or not. And this is the first gate which can decide whether this is hard fail or soft fail, or is it just advisory. In this example, ACL public read is a violation of CIS 215, because it says that S3 must block public access, and you are trying to allow public access. So it can tell you what kind of fix should be applied, and you apply this fix. So the Terraform plan, which is shown on the right side, is pretty much what you would be able to see from normal execution of Terraform plan. I think it's pretty cool because you actually can see the fix inline, control, what kind of attribute was affected, what kind of resources, in addition to traditional which line was changed or was affected, which file, and so on. So there are different levels or different modes how it can fail. For example, hard fail is a plan fails and nothing goes to downstream provider, or soft fail, which will just warn you, and it will help if you're doing some migration. Then it can tell you that, okay, it's time to fix it. Or advisory will simply write audit log, and it will just pass through. So I really want to know your feedback on this, and think about this, that operational rules can rewrite the source code of the modules. Currently, I'm doing this for Terraform AWS modules, but I will explain how to do this for anything else, I think, on the next slide. And then there is OPA, which can check that this plan, which was generated, actually is okay or bad. And then there is Compliance.tf AWS provider, which catches raw resources. It can catch any type of resources, whether it's coming from module or raw resources. It doesn't really matter. So feedback is welcome. And let me explain how things are built, right? So I will explain using different tools how you can build it yourself. And the first tool, which I use heavily for many years, is HCL Edit. For example, for the way to add lifecycle block inside of resource. You first append block resource, and then you append attribute inside of this block. Very straightforward, and it works perfectly because it's supported by HCL. HCL Edit has a few limitations, but it's not because HCL Edit is bad. It's because HCL specification is implemented this way. Another tool, which is Map.otf, I will put a link. Well, actually, all of the links will be on the last slide. And if you want to do block removal, it's a little bit trickier. Then you can do something like AWK and then write this magic script. If you can't, you can also use different HCL or like Python HCL libraries and convert it like this. Or you can always do manipulation by converting into PyHCL, and then from PyHCL, remove it and then dump it into HCL. But I think AWK is okay here. And we use it in some Terraform AWS modules for quite some time. Okay, and one more about add-in validation. So, for example, the first one is that we add block into a variable, like variable instance type, and then inside of this block we add condition. So this is like first thing, and then if we want to validate that inside of plan this condition was actually there, then we check it using this a little bit magic JQ expression. If we want to do content sanitization, it's not actually very much related to Terraform, I would say, but I still see this quite helpful. For example, you may want to rewrite bucket names for certain things, regardless of what user has specified it, or you may want to do some refactoring as well. So this kind of sed combined with HCL edit is helpful. But for most cases, we don't want to commit secrets into Git, so Git leaks together with pre-commit hooks do the job. So imagine that you have created these small scripts. So what you do now, you have to roll your own module registry. The simplest one is HTTPS endpoint that return a fixed module zip, where inside of that zip, you apply all of your rules, for example, in Lambda, and you point to your Terraform to use this registry. It can be HTTPS or it can be Terraform registry. Like in this case, it's reg.example.com. It's very well documented and it has very small edge cases, I would say. And well, this is a way how Compliance.tf is built internally. Of course, it's not so simple like for real, but to get started and to have your own way of applying operational rules, that's pretty much everything what you need. So I want to highlight once more that there are two things available. Validation is pretty well known, and we have heard about it for many years, that, oh, you need to run policies, OPA, Sentinel, were present for many years. But we are very seldom given options on how to actually transform it without forking modules. So I want you to pick on purpose and know that there are different benefits of each. Speaking of tools, if we are looking into tools which we normally use when we write Terraform code, then it's tflint or pre-commit Terraform hooks or different language service protocols. When it comes to input variables validation, then of course validation block is essential. Yeah, it's a good idea to just reject bad values during plan time so that it's discovered during plan time and not during the apply phase, while it's not always possible. And if you are doing it during plan, then remember that there are precondition and postcondition, which can help quite a lot with cross-resource invariance and provider proxy, which I showed earlier, by proxying AWS requests through Compliance.tf AWS provider can give you hard fail or soft fail, for example, if you want to know immediately and decide early on. Also, detective is still there, so Sentinel and Contest and OPA are good representative, and there are quite a lot of materials and libraries and code and utilities around this, so it's pretty good idea to have it there, but it's already like very last phase, I would say. Well, it's not so last. AWS config and the CloudTrail and Crawler are all detective things. They will only discover when things already executed, right? Most likely it's already too late. So these are resources. Some of these resources I mentioned, HCLEdit and map.otf is by Azure. And Awesome Terraform Compliance is my list of resources which I collect and discover when I work on Compliance.tf. And Compliance.tf itself is a solution which enforces different compliance controls and operational rules for Terraform modules. It has pretty big documentation on different controls and frameworks and mappings and so on. And yeah, that's pretty much it. So thank you very much. Tell me if you have questions.
And I can read them. Thank you so much, Anton. That was a wonderful presentation. Let's go over to the Q&A. If you have questions, please submit them. And if you see good ones, upvote them, because we'll start with the most upvoted one. How do you make sure Terraform Cloud modules are updated automatically without breaking existing deployments?
Can you please repeat one more time?
Yeah. How do you make sure Terraform Cloud modules are updated automatically without breaking existing deployments? I see a lot of environments where we're pinning to a specific version, and that seems wrong because then you miss out on updates, or not pinning, which seems wrong because then things break without you knowing when. What's the right answer?
Yeah, that's a very good question. And I think it's one of the oldest questions which people were wondering. So one thing which helps is that, of course, you pin version, and then as soon as you pin version, you need to run some sort of renovate bot, which actually checks for new version and run sequence of tests. For example, it can be that you open automatically a pull request with new version and test it there, like test new version and try to plan dev environment. For Terraform AWS modules, we strictly follow semantic release process. Well, I don't want to say it strictly because I immediately know cases when we didn't follow it and people were disappointed, to put it mildly. Yeah, we try to do our best. So in general, if you have multiple environments and you can run Terraform plan, then there should be a dependent bot, renovate bot, which checks for new version and try plan there. It should work with every module, including public and private modules. That's yeah.
That's perfect. I think all of your examples were AWS. Will DeWorst says, do you have plans to support Azure?
Well, interesting. Well, I'm kind of watching what Azure people are doing. And it's funny enough that AWS and Azure people live in parallel universe. Azure has quite a lot of good solutions already. They have Azure verified modules concept. They have even book about Azure verified modules, which I shared, I think last week at weekly.tf website. So I'm interested in not just sitting and like making one by one module, because it's kind of boring. I was doing this for last almost 10 years. I'm looking into actually using AI. Have you heard about AI, right? Right. So using AI to propose, to write, to verify, and to do as much as possible what I've been doing. So one of my projects, which I share as Terraform skill, where I share like how I write Terraform code, and this is a basement of any module, so for Azure or for AWS. And probably around September, October, I will share another project where I explain how to write pretty much any module. Not just write, but how to write module on the same quality as Terraform AWS modules, which is a little bit different than writing your internal module, which no one else will be using except your team. So,
absolutely. I think you're the singular person in the world to write something like that. So we'll keep an eye out for that. Ricardo says, are the transformations behind a paywall?
I think Ricardo is referring to transformation for the operational rules. And well, that's a good question. I don't remember. No, actually, I think it's not, because as I said on this slide, that try free with CIS v6 for AWS is free forever, as well as operational rules. So if you open account and try these operational rules, it will be working forever. The only thing which you need is to open free account, which is just click login with Google. So it's not behind paywall.
Perfect. All right, we have 45 seconds for one more question, and it's mine. Can these rules, these transformation validation rules, be run on a git commit hook on a dev machine to kind of push this out to your fleet of developers?
Yeah, absolutely. The only thing which is you can think about this is that these hooks are transformation of any piece of code which you want to consume. So if you put this piece of code inside of your Terraform module source block, then you can proxy this module source through this transformation engine. So it can be Git, it can be S3, it can be I don't know, anything else what go-getter accept as part of Terraform init.
That's perfect. Okay, that's it for our time for today. Thank you so much, Anton. We'll get switched over to the next talk.
Yeah, thank you very much. And good to be here. Thanks.